Let's talk matrices. What is a matrix? Well, it's something that you run into all the time. Anytime you have an array of numbers or a rectangular array of numbers, um, it's a new movie that just came out. I haven't seen that yet. Anyway, they're you're going to have an array of numbers and they're written in brackets and they're usually notated with a capital letter. So this is an array of numbers in a rectangle. This is another array of numbers in a rectangle. Each number in the matrix is called an element indicated A sub ij, where I is the row and j is the column. Okay, so if I wanted to find element A out of A, 1, 3, that would be row 1, column 3, and that's 5. If I wanted to find B, row 2, column 4, row 2, column 4 would be 9. Okay. Each matrix has dimensions, which is the number of rows times the number of columns. So A, there are 2 rows and there are 3 columns. In B, there are 1, 2, 3 rows, 1, 2, 3, 4, and 4 columns. This will not become that important in this lesson, but these are the 2 sizes that we're going to be working with today. And it'll be important in 4.3 and subsequent. Okay. Solving a system using matrices is exactly like what you did to solve using substitution, with just a little bit of change. Okay, so here's what we've got here. If we have 4x plus 3y equals 26, 3x minus 11y equals negative 7. We're going to write it as an augmented matrix using only the numbers in the equation. So we're going to get rid of everything. We are going to line up the x's, the y's, and then the constants. So 4x, 3y equals 26, 3x minus 11y equals negative 7. Okay. Now, if I wanted to solve this equation and solve for the x first, then I would multiply the top equation by 3 and the bottom equation by negative 4. And if I did that, I would get these 2 equations. I am going to do exactly the same thing, but without all this hoopla. I'm going to multiply row 1 by 3 and row 2 by negative 4, and this is the resulting matrix. 3 times 4, 3 times 3, 3 times 26, negative 4 times 3, negative 4 times negative 11, and so on. So I get the same thing, I get just the coefficients. 12, 9, 78, negative 12, 44, 28. Once I do that here, then I add these 2 together. And I get 0x plus 53y is equal to 106. So notice here my second equation now becomes 0, 53, 106. And then when I divide everything by 53, the y is 2. So that would be 0y 2. I'm sorry, 0, yeah, the 1y equals 2. Okay, so now what I want to do is I want to eliminate the y. So the x has been eliminated. Now I'm going to go and eliminate the y. So if I start with these two equations, which is here, if I multiply this equation by -9 and I add them together, then I have an equation that has just the x in it. Normally we would substitute, but in elimination you can eliminate one variable and then eliminate the other. It's kind of the same thing. All right, so if I multiply this row by -9, I get 0, -9, -18. If I add these two rows together, when I add these two, I put it into here. That gives me 12, 0, 60. And then I use my same row, 0, 1, 2. Then if I divide everything by 12, in the top row I get, which is what I would do to solve for y, divide by 12, I get 105, and I already had 0, 1, 2. Now, if I put the x's and the y's back in here, what this means is that 1x plus 0 equals 5, 0 plus 1y is equal to 2, which tells me here that x equals 5 and tells me here that y equals 2. So there's my solution. Now, it's going to seem a bit awkward as we get started, but be patient and we'll get there. Go back and rewind if there is something that you don't understand. Okay, so we're going to start off with a system 9x minus 3y equals 24 and 11x plus 2y equals 1. Okay, so I'm going to start out and I'm not changing anything, I'm just putting it in order. Now it's important that these are in order, the x's, the y's, and the constants. So I have 9x minus 3y equals 24. I have 11x plus 2y is equal to 1. Okay. Step 1. The first thing I want to do is get a 0 in this position. I want a 0 here, but it may take me a couple of steps. So this is where my goal is right here, is to get a 0 in there. So looking at this equation, if I want to eliminate the x's, then I would look at the least common multiple of 9 and 11, which of course is 99. So that means I'm going to multiply row 1 times 11, and then to get an opposite sign, I would multiply this one by -9. So the work here has been done for you. 11 times 9, 11 times -3, 11 times 24, but I'm going to have to do the work here. 11 times -9 is -99, -18, and -9. Now in the notation that we're going to use, this means that I took 11 times row 1 and put it into R1. In our notation, I took -9 times R2 and put it into R2. Okay. All right, so I'm going to leave row 1 the way it is, and my whole goal here is to get a 0 here. And that's what I do. If I add R1 plus R2, then this is eliminated, so I get a 0. -33 plus -18 gives me a -51, and 264 minus 9 is 255. Okay. All right. So I'm close to solving for y.
So what I'm going to do here now is I'm going to leave row 1 the same. So row 1 is going to remain 99, negative 33, 264. But my new row, I am going to divide row 2 by 51, by negative 51. So negative 51 divided by negative 51 gives me 1. 255 divided by negative 51 gives me negative 5. Okay. This tells me that y is negative 5. So I'm halfway home. My next step is to get a 0 in position A12. So my goal now, I'm working here. I want that to be a 0. Well, I know, excuse me, if I add these columns together, I can get a 0 in here if, in fact, these are the same with opposite signs. Okay, so the first thing I'm going to have to do is on here is I'm going to have to turn this into a positive 33. So the least common multiple of negative 31, 33, and 1 is, of course, 33. So I'm going to multiply row 2 by 33. So if I multiply this by 33, then this becomes 0, 33, negative 165, and I'm going to leave this one alone. This is 99, negative 33, 264. So now if I add these two rows together and put it up here, then I've got a 0 in this spot. Okay, so 99 plus 0 gives me 99. Negative 33 plus 33 is 0. 264 minus 165 is 99. Then in the bottom row I left alone. 0, 33, negative 165. So I have my 0 where I want it. Okay. Now my next step is I want this and this to be 1s. Get a diagonal of 1s. Well, that's pretty simple. I can take row 1 and divide it by 99. So that gives me 1, 0, 1. And for row 2, I can divide row 2 by 33. So row 2 divided by 33 is going to give me 0, 1, negative 5. So of course this tells me that 1x plus 0 is equal to 1 and 0x plus 1y is equal to negative 5. So I know my solution is x equals 1 and y equals negative 5. So it is 1, negative 5.
Now, does it check? This is important. Does it check? I can always check and see if I've done it right. Does it check? That means I plug it back into the 1 and -5 into the both equations. So I want to know for my check, does 9 times 1 plus, oops, I'm sorry, that's minus 3 times -5, does that equal 24? 9 plus 15 is 24, so that one checks. And I'm sorry, you can't see it here. I'm just going back to the original equation. All right, I want to know if 11 times 1 plus 2 times -5 equals 1. 11 minus 10 is 1, so it does check. You can always check your solutions. Okay. Now, that seemed like an awful lot of steps, but I wanted to go through it that way to make sure that you saw what we were doing in each one and how it correlates to what you would do if you were solving it using substitution. Okay, but what we're going to do now is we're going to take that and we're going to start combining steps. Okay, same equation. I'm going to start out with 9, -3, 24, 11, 2, 1. Knowing that my ultimate goal is to get 1, 0, some number, 0, 1, some number. Okay, so in the first step is to get a 0 in this position. Well, it took us 2 steps last time, but I think we can do it in 1 step. Okay. All right, so that means I'm going to take, if I multiply this by -9, I'm sorry, by 11, and this by -9, and add them together, then I can put them in there. Okay, so let's start out. I'm going to try to be consistent with my colors here. All right, so if I multiply this times 9, one more time, times 11, and this times -9, this gives me 99, -33, 264, -99, -18, -9. And if I add them together, then I get 0, -51, 255. So once again, the LCM is going to be 99. Multiply row 1 by 11 and row 2 by -9. So I've got my 0, -51, and 255. Okay. All right, so now I'm going to get a 0 in the position of A2, and I'm just going to combine, 1, 2, a couple of steps. Okay. Well, if I look at this equation here, 51 is a multiple of 3. 17 times 3 is 51. So what's going to happen here is I am going to take row 1 times -17 and add it to row 2. Okay, so if I take row 1 times -17, that is going to give me -153, 51, -408, and I'm going to add to it 0, -51, 255, and when I add those together I get -153, 0, -153. Okay. Okay, so I've got my zeros where they belong. But my next goal is to get my 1s here. Okay. Well, that's pretty easy to do. I can just take R1 and divide by 153. Negative 153, so that gives me 101. Divide row 2 by negative 51, and that gives me 0, 1, negative 5. So my solution is still 1, negative 5. Let's try one more. All right, so this is going to be a different system. And remember what our goal is. We want a matrix 1, 0, 0, 1, and then some number are going to be over here. And that's a tilde, and it can represent a number. Okay, so if I'm going to start out, I'm going to start out with my system. I've got a 2, I've got a 3, my constant is a 5, I have a 1, a negative 1, and a 0. Remember, my first goal is to get a 0 in this position. Okay, so what I can do to that is if I multiply R2 by negative 2 and add these together, so just to formalize that, I'm going to take R2, 2 times R2 plus R1 and move that into R2. So I'm going to multiply this by 2. That gives me 2, negative 2, 0. And then I'm going to add to that 2, 3, 5. Oops, I'm sorry, it has to be negative 2. God, I'm doing terrible with signs today. So that's negative 2, positive 2, 0. 2, 3, 5. And then when I add those together, I get 0, 5, 5. And I'm going to leave my top row alone for right now. So now I've got to work on getting a 0 here. Get a 0 in A2. So I've got to get a 0 here. So I'm going to have to do something with these that if I multiply them and add them together, that they will result in 0. Well, the LCM of 3 and 5 is 15. Okay, so I think I'll make the top one negative. I have no idea why. So what I'm going to do here is do, let's see, negative 5 times R1 plus R2 and turn that into R1. So if I multiply this by negative 5, that gives me negative 10, negative 15, negative 25, plus multiply this times 3, and that gives me 0, 15, 15. So that gives me negative 10, 0, negative 10. And of course, I have my 0, 5, 5. Okay. So I need to get my diagonal of 1s, which means I want a 1 here, and I want a 1 here. So I think in order to do that, what can I do? I'm going to take R1 divided by 10, negative 10, and that goes into R1, and R2 divided by 5 into R2. So negative 10 divided by negative 10 is 1. 0 divided by anything is 0. And I have another 1. 0, 1, 1. So that tells us our solution is 1, 1. Okay, the end.